Alright, we're going to move on to graphing equations and intercepts. This is week 2 notes. When we say we are graphing an equation, we mean we're graphing all the points that are solutions to that equation. If we look back to the previous page we were working on, you had an equation in two variables, and you found out that the point 1, 2 worked in that equation. That means that the point 1, 2 would be on the graph for the equation of 4x minus 3y equals negative 2. The graph of that equation would be a straight line, and 1, 2 would be one of the points on that line. So we're going to work with another equation, 4x minus 3y equals negative 6, and we're going to find a whole bunch of solutions to that equation, and we're going to do it by graphing just 2 points that work, just 2 coordinate pairs that work in that equation, and then connecting them with the line that represents the equation. Those 2 points are called the x-intercept and the y-intercept. So here's what I want you to do. Split your paper in half right here. On this side, we're going to learn how to find the x-intercept. And on this side, we're going to learn how to find the y-intercept. Alright, now I'm just going to go off on a tangent for a little bit here. You do not have to write down what I'm going to show you in the next minute or so. Just want you to understand it. When we are looking at a coordinate grid, the 4 quadrants, and the x and y axis, x-axis, y-axis, if we're looking at an x-intercept, it's any point that is stuck on the x-axis. So I'm going to put some points here. There's one, there's one. Okay. And I want you to look to see what they all have in common. This point is negative 3, 0 on the x-axis. This point is 1/2, 0. This point is, let's see, it looks like about 4 and 1/3, 0. Let's do one more. Negative 1, 0. What do they all have in common? Hopefully you're noticing that they all have a y value of 0 in common. X, Y, X, Y. Every single one of them has a y value that is 0. So if a point is an x-intercept, it's a point stuck on the x-axis for an equation, the y value will be 0 there. So when we are trying to locate an x-intercept for an equation, what we do is we let y equal 0. Let's write that down. And we put the 0 into the equation, and we solve for the x that goes with it. And you just practiced doing that in the last videos, so let's go ahead and do it. We rewrite the equation. Where the y is, we put a pocket, because we're going to be replacing it with 0. So 0 in the equation. And now we take care of that calculation. 4x minus 3 times 0 is 0. Equals negative 6. Let's see, we don't even need that 0 there anymore. So we can just write the mini equation 4x equals negative 6 and solve that. Before I go on and do that, notice what happened. When we put y equals 0 in the equation, I basically end up just getting rid of the y term and getting this little mini equation 4x equals negative 6. My students call this the cover-up method. If you want to find the x-intercept, cover up the y term because it's going to turn to 0. Alright, going back to finishing solving this. What times x? 4 times what makes 6? How do I figure that out? I divide both sides by 4, undo the multiplication, and I get x equals negative 6/4, which I believe is negative 3/2, which is, isn't that negative 1/2? Alright, so we've just found the x-intercept. It's an x value that will be on the x-axis at negative 1/2. The whole coordinate pair, let's write out the whole coordinate pair. I'm going to write x-int, short for x-intercept. X value negative 1/2. And remember what y is always for an x value, an x-intercept? Y is always 0. Alright, when we come back, we're going to find the y-intercept.